In this video, we're going to go over second derivatives. Second derivatives. So what are second derivatives? Well, we considered, let's say y is equal to f of x, right? Y is some function defined with respect to x. And we were looking at dy by dx. So when we differentiate y with respect to x, we call this f dash of x, right? This was the first derivative. And the first derivative helped us to find the tangent to the curve at a particular point, right? And we used it to find the tangent line, the equation of the tangent, the equation of the normal. So tangent to the curve at a particular point. But now let's consider, now what if we differentiate this again, right? d by dx of dy by dx. And that is what we call second derivative. So this is a second derivative. And basically you're taking your first derivative and you're taking its differentiation again. So the notation for this is d squared y over dx squared. That is how you write your second derivative. That is the notation that we are going to follow. And if you have to write it like this, it's going to be f dash dash of x. So f of x, that is your function. F dash of x is your first derivative. And f double dash of x is your second derivative. And I don't think we are going to discuss this. We probably will in grade 12. But the second derivative tells us about the concavity of the graph, whether it's concave up or concave down. And we check it by looking at whether f double dash of x is positive or negative. So f double dash of x, if it's positive, if the second derivative is positive, then it means the graph is concave up. And if f dash of x is negative, if the second derivative is negative, then it's going to be concave down. All right. But we probably won't need to discuss this, and we will elaborate on more on this in probably the next topic. So, but this is basically what the second derivative is. You take your first derivative and you differentiate it again and you get the second derivative. All right, so now let's move on to the questions. So for the first question, we'll skip some. So we'll do BDFH. If I skip things correctly. No, okay, let's do more number of questions. So we'll do A, C, E, G, and I. So we'll do A, C, E, G, I, and I'll leave you to try B, D, F, and H. And for question 2, let's do B, D, and F. All right. So question A, 1A, is that y is equal to x squared plus 8x minus 4. All right. So you want to differentiate this dy by dx, and we have been used to differentiating things like this, right? If you differentiate the first part, you get 2x. If you differentiate the second part, you get 8. You differentiate the third part, you get 0. So it's going to be 2x plus 8. And let's just quickly go over the rule that we used here, right? So dy by dx is just d by dx of x squared plus 8x minus 4. And you can do it individually, right? This is just d by dx of x squared plus d by dx of 8x, and you just preserve your sign. So if it's minus, you use minus. If it's plus, you use plus. All right. D by dx of 4. Now d by dx of x squared is 2x, of 8x is just 8, and this is just going to be 0. So you get 2x plus 8. And now we need to differentiate this again. dy by dx, that is going to be your second derivative. So this is d squared y by dx squared. And that is, if you differentiate this, you're going to get 2. So that is your answer. So let me have my laptop by my side so I can check my answers. But pretty much, it's going to be the second derivative, which is what the question asks you to find, is going to be 2. part C. You have y is equal to 2 minus 6 over x squared. 2 minus 6 over x squared. So let's take the derivative. dy by dx is going to be 0, or you just write it as d by dx of 2 minus 6 over x squared. Then you can do it term-wise, right? D by dx of 2 minus d by dx of 6 over x squared. And remember, d by dx of 2 is just 0, minus, you can bring 6 out, because 6 is a constant, multiplying the function 1 over x squared. And now, when we solve this, we get 6 d by dx. And remember, 1 over x squared, you can write it as x to the power minus 2. So you can write this as follows. And now, if you simplify this, you have a negative sign here. You have a negative sign here. You have negative 12 here. So you are going to get positive 12 over x cubed. So that is dy by dx. Now we need to differentiate this again. So you get d squared y by dx squared. You want to differentiate 12 over x cubed, right? And so we bring this 12 outside the d by dx operator. And we can write 1 over x to the power 3 as x to the power minus 3. So this is going to give us 36 x to the power minus 4, right? You bring minus 3 to the front, you multiply it by 12. So you get minus 36, and then you subtract 1 from your power. So you are going to get this expression. And that is going to be your second derivative. Alright, and I hope this was clear. So you can bring this 12 out, and you're differentiating 1 over x to the power 3. So that you can write it as x to the power negative 3, and then you bring your negative 3 to the front. When you multiply it by 12, you get this, and then you have to subtract your exponent by 1. So you get this expression. Alright. And e is 4x minus 9. E is, you have y is equal to square root of 4x minus 9. Right? Alright, so I can write this as 4x minus 9 to the half power. Now I can find dy by dx. dy by dx is, I can bring this half to the front, and then I have 4x minus 9, and half minus 1 is going to give me minus half. But remember, right, so you bring this power to the front, so you have half, and then you subtract 1 from your new power. So half minus 1 is going to give you negative half. Alright, but ani x dega? No, right? Ani x made. So therefore, you have to differentiate x. And that is what we have covered in the chain rule chapter. So if you simplify, you get 4. So now, when you simplify this expression, right, 4 times half is going to give you 2. And then this part, you can write it in your denominator. So you can write it as square root of 4x minus 9. So that is your dy by dx, right? However, because we want to take the second derivative, I will choose to write it as 2 times 4x minus 9 to the minus half power. Now, let's differentiate it again. D squared y by dx squared. And that is going to be 2 times you bring your new power down. So negative half, and you have 4x minus 9. And negative half minus 1 is going to give you negative 3 by 2. However, ani x tega was this x, right? So now, because it was not x, ani x made. So that's why it was 4x minus 9. So you have to differentiate this again. And when you do so, you are going to get, this will cancel out, and you are going to get 4 from here. So you get negative 4, and then if you simplify, you are going to get the square root of 4x minus 9 cubed. This is going to be how your final solution is going to look like. Alright, so now I hope you can simplify from this expression to this expression. Alright, so you get your negative sign from here. These will cancel out, 2 and 2. You get 4 from here, so you have negative 4. And this one, you can write it as 4x minus 9. The 1 over 2 is square root. So you have square root of 4x minus 9, but you need to multiply this by 3. And then that has to go into the denominator because it's a negative power. Alright, so I hope that explanation was clear and how you got this expression. Okay. So we are done with 3 questions. For g, you have y is equal to 2x minus 5 over x squared. Y, and for g, we have 2x minus 5 over x squared, I think. Alright, so I can simplify this. I can write this as 2x over x squared minus 5 over x squared. And this I can write as 2 over x because 1x from the numerator and the denominator cancel out, and 5 over x squared. And even better, I can write this as 2x to the power negative 1 minus 5x to the power minus 2. And now let's differentiate this. So dy by dx is going to be minus 2 because I bring the negative sign to the front, x to the power negative 2. Right? You bring this one here, so you get minus 2, and then when you decrease the power, you're going to get this. Minus, you bring minus 2 to the front. 5 times minus 2 is going to give you minus 10. And minus of minus 10, that is going to be plus 10, x to the power minus 3. Alright, now let's differentiate this again. And that is going to give us minus 2, you bring to the front, you're going to get 4, x to the power minus 2 minus 1 is negative 3. And similarly, you bring negative 3 to the front. You're going to get 10 times negative 3 is negative 30. Plus minus is going to give you minus. X to the power minus 4. And that is going to be your final solution. 4x cubed minus 30 x to the power 4. Alright, and if you want to simplify this, you can even write this as 4x minus 30 divided by x to the power 4. This is also okay. Alright, how did I get this? I multiplied by x in the numerator and the denominator, and x cubed times x is going to give me x to the power 4. Alright, we are done with g, and finally I is 5x minus 4 divided by root x. So you have y is equal to 5x minus 4 divided by square root of x. And this I can simplify again. I don't need to use the product rule here. I can, but what's simpler is that I can write it as 5x divided by root x minus 4 over root x. And this one, I can write it as 5 root x if you simplify here, because remember, x is just square root of x squared, right? If you simplify this, you get x. So you just have 1 canceling out with in the square root of x in the denominator. Minus 4 x to the power minus half, right? And you can write this as x to the power half. And now you can find dy by dx quite easily. That is going to give you bring your power to the front. So that is going to give you 5 over 2 x to the power minus 1 by 2, right? Half minus 1 is going to give you negative half. And then you bring this power to the front, and you get 4 times negative half is negative 2. And then you have minus of minus 2. That is going to be plus 2 x to the power minus 3 over 2. Right? Negative half minus 1 is minus 3 over 2. And now I can take the second derivative. And when I do so, I bring this to the front. And that is going to give me minus 5 over 4. If you think about multiplying by half times 5 over 2 is going to give me negative 5 over 4. X to the power minus 3 by 2. And if I bring this to the front, I am going to get negative 3x to the power negative 5 over 2. Why? Because 2 times negative 3 over 2, and 2 and 2 cancel out, is going to give me negative 3. Plus minus is going to be minus. So plus something minus 3 is going to give me minus 3x to the power. And then negative 3 by 2 minus 1 is going to give me negative 5 by 2. So we can leave our answer like this, but I think the textbook simplifies this a bit further. So we can write this as minus 5 over 4 and then square root of x cubed. And we have minus 3 x5 square root. Alright. So we can simplify this as if I multiply by x, right? If I multiply by x on my first term, I am going to get So I need to multiply. So I have 4 something. So let me just multiply by 4 here. So I have minus 5 over 4 x cubed, right? Square root of x cubed minus 12 4 times square root of x5. Now if I multiply my first term by x, right? If I want to put this x inside the square root, it's going to be x squared. So think about it. If I have x squared times x to the power cube, then I can sort of distribute the square root over the two terms, and I'm going to get x outside, right? So let me just write this here. X squared times x cubed is going to be square root of x squared times square root of x cubed, and this is just x times square root of x cubed, which is what we had in the denominator. Alright, so now that we know that, we can simplify it like this. So after multiplying by x, we are going to get the expression as follows. And we can factor out the negative sign. So if you factor out the negative sign, you are eventually going to be left with this expression. That is the one in the textbook, but this is nonetheless correct. So that is enough as well. But if you simplify further, you get this expression in your textbook. Alright, so we are done with I. Question 2. So we are asked to find the second derivatives again. So it's very, very similar, right? So B is just, so we are given f of x is equal to 4x squared minus 3 divided by 2x. So you can distribute this as follows. And you can write this as 4 divided by 2 is 2, x squared divided by x is x, minus 3 over 2 times x to the power negative 1, if you think about it. So I factored out a 3 over 2, and then I had 1 over x, and 1 over x is just x to the power minus 1. So now that I've written it like this, f dash of x is just going to be, I differentiate this part. So if I differentiate the first term, I get 2. If I distribute the second term using the power law, I get negative 1, x to the power minus 2, right? And if I simplify this, I am going to get, so you're going to get minus minus, which is going to be plus, and you have x to the power minus 2. Let's differentiate it again. Derivative of 2 is 0. So we are just having this term, right? So you have 3 over 2. You bring minus 2 to the front, x to the power minus 3. So 2 and 2 cancel out. You get minus 3 over x cubed. So that is your answer. And we are done with B. Let's do D. F of x is equal to 1 minus 3x to the power half. Alright, so now let's take the derivative. So you have half, you bring the power to the front, 1 minus 3x to the power minus half, right? Half minus 1 is minus half. But ani x tega, made, so you have to differentiate it again. And once I finish differentiating the second part, I will get negative 3. The derivative of this part is going to be negative 3, right? So eventually you get negative 3 over 2 if you simplify. 1 minus 3x to the power negative half. Alright, so now we need to take its derivative again. So we have minus 3 over 2 times minus half times 1 minus 3x to the power minus 3 by 2, right? So I brought this power to the front. I had this already, so I multiplied them together. And I have 1 minus 3x to the power negative 3 by 2. But ani x tega? No, right? So you need to differentiate it again. And now, here you get 3 over 4 if you simplify, right? If you simplify this, you get 3 over 4. You have 1 minus 3x to the power negative 3 over 2. And then from this side, you get negative 3. So eventually, your final answer is going to be negative 9, because this and this you multiply together, 4 square root of 1 minus 3x squared. That is going to be your final answer. Sorry, cubed, not squared, cubed. Because square root of something cubed is going to give you this expression. Alright, so I hope the simplification makes sense. Remember, this was positive, so your final answer must be negative. Negative, negative, you got a positive here. Alright, so this should be your final expression. And we're going to do f as well. So you have 15 divided by cube root of 2x plus 1. So the final f is y, or f of x, is 15 is the cube root of 2x plus 1. So I can write that as 2x plus 1 to the power 1 over 3. And even better, I can write it as 15 times 2x plus 1 to the power negative 1 over 3. So that is how I can express f of x. And now to find f dash of x, I just use the power rule. 15 times, you bring negative 1 over 3 to the front, and then you have 2x plus 1 to the power negative 4 over 3. Negative 1 over 3 minus 1 is going to give you negative 4 over 3. But ani extega made, so you have to differentiate it again. So now, negative 1 over 3 times 15, that is negative 5. And you have 2x plus 1 to the power negative 4 over 3. And this derivative is going to give you 2. So negative 5 times 2 is going to give you negative 10. Let's find f double dash of x. That is negative 10. You bring negative 4 over 3 to the front. You have 2x plus 1. And negative 4 over 3 minus 1 is going to give you negative 7 over 3. Times ani extega made, right? So you have to differentiate it again. So 2x plus 1. And eventually, when you simplify everything, I'm going to leave the simplification to you, is you're going to get 80 over 3, 2x plus 1, negative 7 over 3. And I can write this as 80 over 3 times cube root of 2x plus 1 to the power 7. So I'll leave the simplification for you to think about how to simplify this on your own. But this is going to be your expression. Alright, so we're done with question 2. Alright, so we're done with 1 and question 2. Question 3. Given that y is given by this expression, we just need to find dy by the first and the second derivatives. 2x minus 1 to the power 4. So let's find dy by dx. Just do term-wise differentiation. You differentiate this, you're going to get 4. You keep your sign, minus. You differentiate the second part. So you need to differentiate 2x minus 1 to the power 4, right? So you have 4 minus, you bring your 4 to the front, 2x minus 1, and then you need to decrease your power by 1, right? So 3. But ani extega made, so you need to differentiate 2x minus 1 again. And when you do so, you are going to get, when you differentiate this, you are going to get 2. So now I will get 4 minus 8, 2x minus 1 cubed. That is going to be my dy by dx. If I want to find d squared y by dx squared, that is going to be, I do term-wise differentiation again. So derivative of 4 is 0. So I need to differentiate just the second term. And my second term is 2x minus 1 to the power 3. And now, I just bring this to the front, right? So negative 8 times 3 is negative 24. 2x minus 1 squared, because I decreased the power by 1. But ani extega made, ani 2x minus 1 debate. So now you need to differentiate it again. And your final answer, when you differentiate this, you're going to get 2. And your final answer is going to be negative 48, 2x minus 1 squared. And that is d squared y by dx squared. And we are done with question 3. So we are given, for question 4, we are given f of x is equal to x cubed plus 2x squared minus 3x minus 1. So we need to find f of 1, f dash of 1, and f double dash of 1. So f of 1 is just you substitute 1 here, right? Minus 1. So 2 times 1 squared. So that is going to be 1 plus 2 minus 3 minus 1. So that is going to be negative 1. F dash of x. So you just take the first derivative of this function, and that is going to give you 3x squared plus 4x minus 3, right? I'll encourage you to do the derivative on your own. And f dash of 1 is going to be 3 plus 4 minus 3. And that is just 4. Now let's take the second derivative. So you differentiate this, right? And if you differentiate it, you're going to get 6x plus 4. And f double dash of 1 is going to give you 10. And we are done. So let me just erase this quickly. Question 5. So we are given f dash of x. The first derivative of something is 3 over 2x minus 1 to the power 8. And I can write this as 3 times 2x minus 1 to the power negative 8. So now let's find f double dash of x. So that is going to be 3 times negative 8. You bring your power to the front. 2x minus 1 to the power negative 9, right? You decrease your power by 1. But ani x tega, made, so you need to differentiate it again. So now when you differentiate this part, you are going to get 2. So if you simplify, you get negative 48, 2x minus 1 to the power negative 9. And that is it. So your final solution is negative 48, 2x minus 1 to the power 9. Question 6. We are given, so let me just erase this. F of x is this expression. I can write this expression as 2 times 1 minus 2x to the power negative half. And I encourage you to think about how I wrote this expression as this, but it should be obvious. So now if I take the first derivative, that is going to be 2 times negative half, right? 1 minus 2x to the power negative 3 by 2. So I brought the power to the front. I multiplied by this constant, which is already there. I wrote my expression with 1 less power. So negative half minus 1 is going to give me negative 3 by 2. But ani x tega, made, so d by dx of 1 minus 2x. So I'm going to get negative 1 from here because these cancel out. I have 1 minus 2x to the power negative 3 by 2. And this is going to give me negative 2. And when I simplify it, I get this expression. So now I need to take the second derivative, right? So that is going to be 2 times minus 3 over 2. You multiply them together, right? You have 1 minus 2x. And if you decrease the power by 1, you get negative 5 by 2. So you keep your constant. You bring your power to the front. So you have negative 3 by 2. You have your expression to the power, which is 1 less than negative 3 by 2. That is negative 5 by 2. But ani x tega, made, so you need to differentiate it again. So remember, your d by dx of x to the power n is nx n minus 1 only works if this is x. But here we have 1 minus 2x. So if we have that, we need to differentiate our expression inside again. And 2 and 2 will cancel out. We are going to get a negative 2 from the derivative, right? So now if you simplify, you are going to get 6 times 1 minus 2x to the power negative 5 by 2. And you can write this expression as 6 square root of 1 minus 2x to the power 5. And that is going to be your final answer. So I hope the explanation was clear. And it's also clear how I wrote the answer in this form. But now I need to find f double dash when x is equal to 4. So f double dash of 4, I just substitute 4 into this expression. 6 square root of 1 minus 8. If I substitute 4 here. I think I made a mistake somewhere. But if I substitute 4 here, 1 minus 8 is going to be negative 7. And negative 7 to the 5th power is still going to be negative. And that should not be possible. So I think find the value of it should be f double dash of negative 4. And if that is the case, then I have 9 to the power 5 inside. So remember, 9 is 3 squared to the power 5. So it's just going to be 3 to the power 10. You have 6 over 3 to the power 5. So that is 3 times 2 divided by 3 to the power 5. So that is going to give me 2 over 3 to the power 4. That is 2 over 81. So if you want your answer to match the textbook, then it's not f dash of 4. This is undefined. It has to be f double dash of negative 4. But I'll check it for you. Alright, so if it's 4, then it actually is undefined. So I just checked it for you. And yeah, so you're supposed to find f double dash at negative 4. It's supposed to be negative 4. So now question 7 is quite straightforward. So you just want to find dy by dx and the second derivative. And you want to plug in 0, 1, 2 and see if it's positive, negative, or 0. So I'll leave that for you. And I'll move on to question 8. So a curve has this equation. So I need to find the range of values of x for which both first and second derivatives are positive. Alright, so let's just find dy by dx. That is going to be 3x squared, right? Minus 12x, if I differentiate this, minus 15. And I can factor out a 3 here. Right? If I factor out a 3, I have this expression. And remember, I can factorize this. And if I factorize this, I am going to get this expression. X minus 5, x plus 1. So x squared plus x minus 5x is going to give me minus 4x times minus 5. So you can just use the sum and product method to factorize. And remember, when we did quadratic inequalities, we just plotted this on a number line, right? So from here, I get x is equal to negative 1. That is going to give me 0. So I put negative 1 into this expression. The whole thing is going to be 0. And if I put 5, it's going to be 0. And if I put something that is bigger than 5, right? So if x is bigger than 5, then my first term is positive, my second term is positive. So overall, everything is going to be positive. If it's less than 5, but bigger than negative 1, then this is going to be negative, but this is going to be positive. So negative times positive is going to give me negative. If it's less than negative 1, then this is obviously going to be negative, right? This is going to be negative, and this is also going to be negative. So that is going to negative times negative is going to give me positive. All right, but I also need d squared y by dx squared to be positive. And that is the expression. So if I differentiate this, I am going to get 6x minus 12, right? And 6x minus 12, I need to solve it to be positive. So 6x minus 12 bigger than 0, 6x bigger than 12, if I add 12 on both sides, and I need x to be bigger than 2. So I just divided by positive 6. So x bigger than 2. However, if x is bigger than just 2, let's say 2 is somewhere here, but if it's less than 5, then this might be positive, but this is going to be negative. So the only value of x that is going to be satisfying both is going to be here. So it can't exactly be equal to 5. If it's 5, then your dy by dx is going to be 0, right? So it's not equal to 5, but if x is bigger than 5, then automatically x is bigger than 2. So this is the condition that you need for both your first and your second derivative to be positive. Alright, so this is the condition, x bigger than 5. So question 9 is your proof condition, proof question, so we'll go over that. So we're done with 8. The condition is x bigger than 5. Alright, so the proof question is y is equal to x squared minus 2x plus 5. So let's just quickly find the first and second derivatives. So dy by dx is going to be 2x minus 2. d squared y by dx, you differentiate this, you are going to get 2. It says show that, so let's just take the left hand side. It's 4 d squared y by dx squared plus x minus 1 dy by dx. And now let's just substitute in values. 4 d squared y by dx squared, this is 2. X minus 1 times dy by dx is 2x minus 2. And that gives me 8 plus 2x squared minus 2x minus 2x plus 2. So if I expand it out, I get this expression, and I get 8 plus 2x squared minus 4x plus 2. And that simplifies to 2x squared minus 4x plus 10. And if you remember, this expression, if I factor out to 2, I have x squared minus 2x plus 5, right? And that is just y. So it's just going to be 2y. And 2y, remember, is your right-hand side. So that is your proof. All right. We're done with 9. And question 10 is very, very similar. So you have y is equal to 4 root x. And you can write this as 4 times x to the power half. dy by dx is going to be 4 times half times x to the power negative half. And that is just going to be 2 times x to the power negative half. And that is just 2 over square root of x. And d squared y by dx squared is just going to be d by dx of this expression, right? 2x to the power negative half. So when I do that, I get 2 d by dx of x to the power negative half. So you bring negative half to the front, and you have x to the power negative 3 by 2. And that gives you minus 1 times x to the power negative 3 by 2. All right. So now we have dy by dx and d squared y by dx squared. Now I do the same thing as I did. So let me just erase this very quickly. The proof was very, very straightforward. You have 4x squared. What is d squared y by dx squared? Well, that is just this expression, right? That is negative 1 over square root of x cubed. That is how you can write this. Plus 4x dy by dx is just 2 over square root of x. That is going to be y. Oh, sorry. That is our left-hand side. So now let's try to simplify this. You have negative 4x squared. In the denominator, you have x to the power 3 over 2. And here you have 8x in the numerator. In the denominator, you have square root of x. So if you simplify this, you are going to get 4 root of x plus 8 root of x. Right? X squared, so x, and if you simplify this expression, you're going to get this. And 2 minus 3 over 2 is just 0.5. So that is how I got to this point. So this is just 4 root of x, and 4 root of x is just y. So we just showed this. Y is the right-hand side. So hence, left-hand side is the right-hand side, is how you prove the equality. So we are done. Question 11. So a curve has this equation. So show that dy by dx is 0 at these values. So find dy by dx first. You differentiate this. When you differentiate, you are going to get 3x squared plus 4x minus 4. Right? And now let's find the sum and product. Let's just factorize this. The sum is 4. The product is minus 12, right? And when you use the sum, now why am I using the sum and product? Well, I know that I have two clean numbers, right? It's already given to me in the question that two clean numbers are going to be the zeros. So it makes sense that I'm going to use sum and product rule. So the two numbers are going to be two numbers that give me 4 and product. That is going to be 6 and minus 2, right? Positive 6 and minus 2. Their sum is going to be 4. Their product is going to be negative 12. So you have 3x squared plus 6x minus 2x minus 4. And 3x, if you factor out, you get x plus 2, right? And you minus x, you get x plus 2. So you have 3x minus 2, x plus 2. That is going to be your factorization. So x is equal to negative 2. You have dy by dx is equal to 0. This because this term will be 0. And x is equal to, from this, you are going to get 2 over 3. And that is going to produce dy by dx is equal to 0. So basically, it's very straightforward, right? if you put negative 2 here, this term is going to be something. This is going to be 0. Something times 0 is 0. So remember, dy by dx is 0. And similarly, if you put negative 2 over 3 here, this term is going to be something. This term is going to be 0. And therefore, you are going to get dy by dx is 0. So that is 11a. And I need to find the value of d squared y by dx squared. Alright, at these values. So d squared y by dx squared is just d by dx. Now don't use this expression. If you use this expression, you will have to use the product rule or you have to expand it out. Let's just use this expression. That is what's dy by dx. That is easier to work with, right? 3x squared plus 4x minus 4. And if you differentiate, you're going to get 6x plus 4. And now you substitute negative 2, right? So d squared y by dx squared at x is equal to negative 2 is just 6 times negative 2 plus 4. Negative 12 plus 4 is negative 8. So that is one value that they're looking for. And d squared y by dx squared when x is equal to 2 over 3, that is going to be 2 over 3 plus 4. I just substituted here, and that gives me positive 8. Alright, so negative 8 and positive 8. Those are my solutions. So this is part B. And part A, we proved it here. Alright, so we're done with question 11. And finally, question 12. So a curve has this equation. And given that dy by dx is equal to 0, and d squared y by dx squared is equal to half at x is equal to 2, and we need to find a and b. Alright, so we can write y as ax over x squared plus b over x squared. And that gives me y is equal to a over x plus b over x squared. So now I can find the derivative. dy by dx is just going to be, now I'm going to do it quickly, but you are going to see this expression. So I differentiated this in my head and I get this expression, but I encourage you to try to differentiate it on your own and see how we got this. So when x is equal to 2, dy by dx is 0. So 0 occurs when I substitute 2 here. So 2 squared is 4 minus 2b, 2 cubed is 8. And I can simplify this, right? I can write that it as 2b over 8. I send this to my left-hand side. I get negative a over 4. 2b is minus 2a if I multiply by 8 on both sides. And finally, I am going to get b is equal to negative a. That is my equation 1. But now I need to differentiate this again. D squared y by dx squared. I take this equation and I differentiate it, right? So I have minus a over x squared minus 2b over x cubed. And now I encourage you to try the differentiation on your own, but I believe you are going to get 2a over x cubed plus 6b over x to the power 4. That should be your expression, I think. Yeah. And let me substitute x is equal to 2. Because d squared by dx squared when x is equal to 2, that is given to be half, right? So now I just substitute x is equal to 2 here. So I get 2a over 8 plus 6b over 2 to the power 4, that is 16, is half. So 1 over 4a plus this is 3b over 8 is half. Now let me multiply by 8 on both sides, and that gives me 2a plus 3b is going to be 4. But remember, b is just negative a. So now when I substitute this here, I encourage you to try the simplification on your own. You get this. So a is negative 4. If you solve this, you're going to get a is equal to negative 4. So I know I'm skipping some steps, but I believe you're able to, encourage you to try to figure it out on your own so that you get more practice. And now I can just substitute, b is just minus a. So it's minus of minus 4, so b is just 4. And we are done with this topic. All right.